Hello everyone, so for today we're going to be learning how to perform the differentiation. Okay, differentiation of inverse trigonometric functions. So trigonometric functions. So there are 6 formulas that we have to memorize, become familiar with, for us to be able to learn how to perform the differentiation process. So first, to be able to find the derivative of arc sine of u with respect to x, remembering that u here is a differentiable function of x, and that is equal to 1 over the square root of 1 minus u squared, and we still have to multiply it to the derivative of u with respect to x. As for the derivative of arc cosine of u with respect to x, you just copy the same formula for arc sine. That's 1 over the square root of 1 minus u squared times the derivative of u with respect to x. You just have to put a negative sign. So it's negative 1 over the square root of 1 minus u squared times the derivative of u with respect to x. And then we have the derivative with respect to x of arc tangent of u. And that is equal to 1 over 1 plus u squared. Still, we're going to be multiplying it to the derivative of u with respect to x. And for the derivative with respect to x of arc cotangent of u, again, we still have to copy. We just need to copy the formula for arctangent. That's 1 over 1 plus u squared. Multiply it to the derivative of u with respect to x. And then you just put a negative sign in the numerator. So it's negative 1 over 1 plus u squared times the derivative of u with respect to x. And then the derivative with respect to x of arc secant of u is equal to 1 over u square root of u squared minus 1 times the derivative of u with respect to x. And for the derivative with respect to x of arc cosecant of u, we just copy the formula for the derivative of arc secant. So arc cosecant of u, it's 1 over u square root of u squared minus 1 times the derivative of u with respect to x. Again, you just need to put a negative sign. So it's the negative of 1 over u square root of u squared minus 1 times the derivative of u with respect to x. So for example, we are going to find or differentiate. We're going to be differentiating the given functions. So let's start with the function y equals arc sine of 3x. So of course this is an inverse trigonometric function, and the first thing that you must do is for us to identify our u. In this case, u is 3x. So applying the formula, the derivative dy dx is equal to 1 over the square root of 1 minus, that's u, 3x quantity squared. According to the formula, you just need to raise u to the power of 2. And then multiply it to the derivative of u, which is 3. So the answer, the derivative of arc sine 3x is equal to 3 divided by the square root of 1 minus 9x squared. Okay, let's have another example. We are trying to find the derivative of y equals arc tangent of x over 4. So this time our u is x over 4. So applying the formula, the derivative dy dx, or you can always use y prime, is equal to 1 over 1 plus, it's supposed to be u, raising it to the power of 2. So x over 4, raise it to the power of 2, and multiply it to the derivative of x over 4. And the derivative of x over 4 is 1/4. So we're going to simplify now. This is 1 divided by 1 plus x squared divided by 16 times 1/4. Simplifying it further, we can just multiply. So this is 1 divided by, we're going to be multiplying this 4 here to each term here in the denominator. So 4 plus, can simplify that, that would be x squared over 4. So simplifying it further, we want to eliminate the fraction. So we are going to be multiplying both numerator and the denominator with 4 here. So multiplying dy dx is equal to 4 divided by 16 plus x squared. And that is the derivative of y equals arctangent of x over 4. So for the differentiation of inverse trigonometric functions, you only need to recall these formulas. Okay, third example. We want to find the derivative of y equals the arc cosecant of square root of 4x plus 1. So our u here is square root of 4x plus 1. Finding the derivative using the formula dy dx. Remember that it is negative 1 over, okay, let me write the formula on the side. So the derivative with respect to x of arc cosecant of u is equal to negative 1 over u square root of u squared minus 1, and we're going to be multiplying it to the derivative of u with respect to x. So negative 1 over u, then we have to copy our u here, the square root of 4x plus 1, and multiply it to the square root of, we're going to extend this fraction bar right here, and we're going to raise square root of 4x plus 1 to the power of 2, and then minus 1 times the derivative of square root of 4x plus 1, which is 4 over 2 square root of 4x plus 1. Again, this is our du dx. Okay, so simplifying, we're done with differentiation, so we're now going to simplify our derivative. So this would be, you can cancel this so that you have 2 left in the numerator. So negative 2 divided by, and then we're going to be multiplying this and this. So multiplying square root of 4x plus 1 and square root of 4x plus 1, we have 4x plus 1. Yeah, remember there are 2 terms. You have to enclose that in a parenthesis. Square root of, and then raising this 4x plus 1 to the power of 2. Square root of 4x plus 1 raised to the power of 2 will give us 4x plus 1, and then you simply copy minus 1. And simplifying further, we have negative 2 over, again copy 4x plus 1, and then what's left inside the radicals is just square root of 4x. But then the square root of 4 is 2. And you have 2 in the numerator, so you can just cancel that out. So therefore, our derivative dy dx is equal to negative 1 over quantity 4x plus 1 square root of x. So you always simplify your answer. Alright, another example. Let's find the derivative of y equals the arc cosine of x over 1 minus x. Alright, differentiating this, dy dx is equal to negative 1 over the square root of 1 minus, copy our u, x over 1 minus x, quantity squared, times the derivative of our u. So the derivative of u is, it's a fraction, and there are variables in the numerator and the denominator, so we're going to use the quotient rule. So 1 minus x quantity squared in the denominator, and then in the numerator we're going to copy 1 minus x first, multiply it to the derivative of the numerator, which is 1, minus, copy the numerator x, and multiply it to the derivative of the denominator, which is negative 1. So we're done with differentiation. We're now going to simplify our answer. Negative 1 divided by the square root of 1 minus x squared divided by 1 minus x quantity squared, times, multiplying this is 1 minus x plus x here. This is 1 minus x, and then negative and negative is positive, divided by 1 minus x quantity squared. Of course, we will be able to cancel our x here. So simplifying further, this part here, we're going to combine these. Okay, so the LCD is 1 minus x quantity squared. So we have negative 1 divided by the square root of 1 minus x quantity squared minus x squared divided by 1 minus x quantity squared, times 1 over 1 minus x quantity squared. Simplifying this further, as you can see here, this is a radical. This is a radical right here, and we're going to extract the square root of this one. So we have negative 1 divided by, we're just going to expand this 1 minus x quantity squared in the numerator. So that's 1 minus 2x plus x squared minus x squared. We're going to put that inside the radical sign and then divide it with 1 minus x times 1 divided by 1 minus x quantity squared. So we can actually cancel this. So we have 1 here as the exponent, and we cancel x squared under the radical sign. So our answer, therefore, dy dx is equal to the negative 1 divided by 1 minus x square root of 1 minus 2x. So those are just few examples of finding the derivatives of inverse trigonometric functions. So we can also apply this when we are doing, or when we're dealing with functions like these. For example, we are trying to find the derivative of arc arc sine x over y plus arc cosine of y over x equals 1. As you can see, this is an implicit function. So still we apply the rule. The derivative of arc sine is 1 divided by the square root of 1 minus x squared over y squared. Remember, we're going to raise, that would be square root of 1 minus u squared. And our u here is x over y. So what we did is just raise it to the power of 2. Okay? But we still have to multiply it to the derivative of our u, which is x over y. So in the numerator, it's y minus xy prime divided by y squared. Denominator is y, multiply to the derivative of the numerator, which is x, so the derivative is 1, and then copy the numerator, multiply to the derivative of the denominator. Okay, and then for our cosine, so it's a minus. So it's a minus of 1 over the square root of, this time it's 1 minus y squared over x squared, and multiply it to the derivative. So it's now xy prime minus y divided by x squared, and on the right side it's equal to 0. The derivative of a constant will always be 0. So we're going to simplify the fraction. This is now 1 divided by the square root of y squared minus x squared divided by y times y minus xy prime over y squared. Minus, simplifying, this is 1 divided by square root of x squared minus y squared all over x squared times xy prime minus y over x squared equals 0. Simplifying the fractions, this is now y minus xy prime divided by y square root of y squared minus x squared minus xy prime minus y divided by, sorry, this should be an x only here because you have extracted the square root already. So that would be x square root of x squared minus y squared equals 0. Okay, so we are now going to multiply both the sides of the equation with this denominators right here, so that we are going to get rid of the fractions. So multiplying, this is now y minus xy prime times x square root of x squared minus y squared minus xy prime minus y times y square root of y squared minus x squared equals 0. Let's try to distribute. So that would be xy square root of x squared minus y squared minus x squared y prime square root of x squared minus y squared minus xy y prime square root of y squared minus x squared plus y squared square root of y squared minus x squared equals 0. And then we're going to leave all the terms containing y prime on the left side. So negative x squared y prime square root of x squared minus y squared minus y prime square root of y squared minus x squared equals, we're going to transfer all the terms that do not contain y prime to the right side. So that's xy square root of x squared minus y squared minus y squared square root of y squared minus x squared. And then we're going to factor out the common terms on the left side, and that is negative xy prime. So factoring out xy prime, negative xy prime, what's left on this first term right here? What's left after factoring out negative xy prime? So we have x square root of x squared minus y squared. And then it's a plus now because we have factored out the negative sign and we have factored out x. So what's left is y square root of y squared minus x squared. Sorry, there should be a negative here. Okay, on the other side also we're going to factor out the common terms. So negative y. So factoring out negative y, what's left inside is x square root of x squared minus y squared plus y square root of y squared minus x squared. And so leaving y prime on one side of the equation, y prime is equal to negative y, copy the numerator, x square root of x squared minus y squared plus y square root of y squared minus x squared divided by negative x quantity x square root of x squared minus y squared plus y square root of y squared minus x squared. And as you can see, we can just cancel this. And so y prime, therefore, both are negative numerator and denominator. So therefore, y prime is just equal to y over x.